Hey everyone, welcome back to the channel. In today's video, we're diving deep into some of the most important and commonly used PySpark functions, explained with simple examples. Whether you're learning PySpark for the first time or prepping for an interview, this video will give you the confidence to handle real-world data tasks using PySpark. Before we jump into the most useful functions in PySpark, let's make sure we have everything set up. First, PySpark needs a Spark session. Think of this as the starting point for every PySpark job. You can create it using the Spark session builder like this. This single block of code initializes the Spark environment locally. You can give your app any name. Here we've called it PySpark function demo. Once you have your session, you're ready to create data frames, transform your data, and run powerful distributed operations, all with Python. Let's also create a sample dataset to work with throughout this tutorial. Here's a simple data frame of sales data. This will give us a nicely structured table of data, just like a table in SQL or a data frame in Pandas, but scalable across a cluster. All right, now that we're all set up, let's dive into the most commonly used PySpark functions and see them in action. Let's start our journey into PySpark functions with two of the most fundamental ones: select and with column. These are your go-to tools for working with columns in a data frame. Select means pick what you want. The selectMon function allows you to fetch specific columns from your data frame, just like SQL select statements. Let's say we only want to see the customer and amount columns from our sales data. Simple, right? This is perfect for narrowing down your dataset to just the relevant columns. Now see the with column function. With column means create or update columns. With column is even more powerful. It lets you create new columns or modify existing ones. For example, let's say we want to calculate a 10% discount on every purchase and add it as a new column as shown. This will add a new column discounted.arch amount where each value is 90% of the original amount. You can chain multiple transformations with column and even use complex expressions inside it. To recap, use select when you want to pick specific columns and use with column when you want to add or change columns in your data. These two functions form the backbone of PySpark DataFrame manipulation, and we'll be using them a lot as we continue. Now let's explore how to extract only the rows we need using two commonly used functions: filter and where. Think of these as your tools for slicing your data based on conditions, similar to SQL's where clause. Filter is row-level filtering. Let's say we want to view only those transactions where the purchase amount is greater than 500. Here's how you do it using filter. This filters the data frame to show only rows where the amount column is greater than 500. Where is SQL-style alternative. The where function does the exact same thing as filter. You can use either based on what feels more readable to you. As you can see, where even allows you to pass conditions as SQL-like strings. You can combine multiple conditions using logical operators for and, or, and not. Let's find customers from the USA who spent more than 1,000. Always wrap each condition in parentheses when combining them. That's a common gotcha. In summary, both filter and where help you drill down into your data with precision. Use whichever suits your coding style. They're functionally equivalent. All right, now it's time to talk about one of the most powerful combos in PySpark, groupBy and ag. These functions allow us to summarize and aggregate our data, just like the groupBy clause in SQL. Let's say we want to find out how many orders were placed in each country. Here's how you'd use groupBy with count. This will return each country along with the number of rows or orders associated with it. Now, what if you want to calculate more than just count, like average, sum, or max? That's where ag comes in. It lets you apply multiple aggregate functions together. This groups the data by country and calculates both the average and maximum purchase amount. You can group by multiple columns too. For example, if you want to group by both country and gender, this gives you deeper insights like how purchasing behavior varies by both geography and gender. So whether you're generating business insights or preparing data for machine learning, groupBy and AGG are essential tools in your PySpark toolkit. Next up, let's talk about how to sort your data using orderBy and sort in PySpark. These functions help you arrange your data frame rows in ascending or descending order based on one or more columns. Let's start with a simple example where we want to sort products by price in ascending order. This will list all the rows sorted by the price column from lowest to highest. If you want to sort in descending order, let's say most expensive products first, use desc from the PySpark SQL functions module. You can also sort by multiple columns. For example, sort by category and then by price. This first sorts by category alphabetically, Then within each category, it sorts by price in descending order. Now you might wonder, what's the difference between order by and sort? Well, they're practically the same. Sort is just an alias for order by in PySpark. You can use them interchangeably. But if you're chaining with other transformations, order by is usually preferred for readability. Sorting is especially useful for reports, leaderboards, or just exploring your data effectively. Now let's talk about cleaning up your data frame, specifically with drop duplicates, and distinct. These are key tools for data wrangling in PySpark. First, drop is used to remove one or more columns from your data frame. Let's say we want to remove the column named discount, or you can also pass multiple columns. This is useful for cleaning up irrelevant or sensitive data. Next, drop duplicates helps you remove rows that are exactly the same across all columns, or a subset of them. Here's how to drop fully duplicated rows. If you only want to drop duplicates based on specific columns, like customer ID and email, you can do this. This ensures you don't accidentally double count records. Distinct is another way to drop duplicates. Distinct is almost the same as drop duplicates, but it works on the entire data frame and is a bit more concise. Use it when you need to ensure all your rows are unique across all columns. These methods are must-haves when you're dealing with messy or repetitive data. When you're working with big data, encountering missing or null values is almost inevitable. In this section, we'll tackle nulls using three powerful functions: fillNA, dropNA, and replace. FillNA lets you replace null values with a default value of your choice. Let's say we want to fill all missing values in the salary column with 0. You can also fill all nulls in the data frame at once. Just make sure the replacement type matches the column type. dropNA helps when you want to remove rows that contain null values, to drop any row with at least one null field, or to only drop rows where all fields are null. You can also limit this to specific columns. Now let's see replace function. Replace is used for substituting specific values, not just nulls. For example, to replace NA with unknown, or to replace multiple values in a single go. Handling missing data smartly is crucial to building accurate models and reports. In large-scale data processing, combining datasets is one of the most common and powerful operations you'll perform. And that's exactly what the join function in PySpark enables you to do. Joins help you enrich, filter, or restructure your data by merging two data frames based on common fields. Let's say we have two data frames, employees and departments. To join them based on the dept ID, the syntax looks like this. This performs an inner join by default, only returning rows where dept ID matches in both data frames. PySpark supports several types of joins beyond just inner, each serving a different analytical purpose. 1. Inner join returns only matching rows in both data frames. 2. Left or left outer join returns all rows from the left data frame and match rows from the right. Missing matches will show as null. 3rd. Right or right outer join, opposite of left join, all rows from the right and match from the left. 4th. Outer or full outer join returns all rows from both data frames, matched where possible. 5. Left a semi-join returns only rows from the left data frame where a match exists in the right, but only includes columns from the left. 6th. Left anti-join returns only rows from the left data frame where no match exists in the right, like a filter for non-matching records. Here's an example of a left anti-join. This is useful when you want to find unmatched records. Say employees not assigned to any department. Let's talk about handling column name conflicts. If both data frames have a column with the same name, other than the join key, PySpark will automatically rename them by appending suffixes like _left and _right. You can manually control this by renaming or selecting specific columns post-join using select. Joins are a cornerstone of big data processing. Whether you're filtering records, enriching datasets, or identifying anomalies, understanding the various join types gives you massive flexibility and power. In real-world data processing, we often need to apply conditional logic, similar to SQL's case, when, or Excel's if statements. In PySpark, this is achieved using the powerful combo of when and otherwise functions from PySpark SQL functions. Let's look at the basic syntax. This code adds a new column called salary category based on the value of the salary column. Now let's see how it works when evaluates a condition. If it's true, it returns the corresponding value. You can chain multiple when clauses for multi-level logic. Otherwise, handles all the cases that didn't match any when, just like nested if-else statements, but optimized for distributed processing. Now let's see an use case. Grading students. Imagine you have a marks column and want to classify students as pass or fail. You can apply similar logic for tagging, bucketing, or even filtering out rows based on complex rules. When and otherwise are essential tools in your PySpark toolkit, giving you flexible and readable control over your data logic. Sometimes we need to perform operations across a window of rows instead of the whole data frame, like calculating a running total, ranking employees within departments, or finding the previous value in a time series. This is where window functions in PySpark shine. A window function allows you to define a partitioned subset of data and perform calculations within that window, without collapsing the rows like a groupBy would. Command 1. Think of it as a way to analyze data row by row while still looking at neighboring rows. To use a window function, you first import the necessary module and define a window specification. Here, we're creating a window that partitions data by department and orders each partition by salary. Let's check out some commonly used window functions. Row number assigns a unique sequential number to each row in the partition. Rank, similar to row number, but assigns the same rank to rows with equal values. Dense rank, like rank, but with no gaps in ranking values. Lag and lead, access the previous or next row's value. Sum and AVG, compute running totals or averages. Let's see the example where this adds a column that ranks employees by salary within their department. Let's see an example of use case. Running total need a running total of sales for each product. This adds a cumulative total of sales per product, ordered by date, super useful in financial or time series analysis. Window functions are your go-to for complex analytics without aggregating away rows. They're incredibly useful when you need row-level context in your data transformations. Before you run that final action or transformation on your data frame, wouldn't it be great to peek under the hood and understand how Spark plans to execute your code? That's exactly what Explain It was for. It's your window into Spark's execution plan, helping you debug and optimize your pipelines. Explain is a method you can call on a data frame to print out its logical and physical plans, how Spark is going to execute the transformations and actions you've written. When you run this, Spark outputs the steps it'll take, from scanning the data, applying filters and transformations, to performing the final aggregations. It is useful for debugging, helps identify inefficient operations before you execute them. Optimization. See if operations like predicate pushdown or broadcast joins are being applied. Understanding DAGs. Learn how Spark builds its directed acyclic graph behind the scenes. You can also use DFF explain true to get even more detailed output, including the parsed logical plan, analyzed logical plan, optimized logical plan, and physical plan. Use explain regularly, especially when dealing with joins, large transformations, or complex queries. It'll save you from costly mistakes and performance bottlenecks later. That's it for today's crash course on essential PySpark functions with examples. Let me know in the comments which functions you found most useful, or if you'd like a part 2 with even more advanced functions. Don't forget to like, share, and subscribe for more data engineering content. Thanks for watching, and I'll see you in the next one.